This video will show you how to identify whether a function is continuous at a given number or given numbers. In this particular example, a function is a piecewise function, meaning the function can be expressed in three different ways depending on where the value of x is. So when x is smaller than -3, the function is -3 minus x. But when the function is at x between -3 and 3, the function follows the graph of 9 minus x squared. But when the function is already equal to 3 and bigger than 3, the function behaves as 6x minus 18. So how do we determine whether this piecewise function is continuous at 3 and -3 without graphing the function? Surely if we graph the function, then we can easily identify, oh, it's not continuous or it's continuous at 3 or -3. Now since we have two numbers to consider, let's take it one at a time. Let's start with x equals 3. So let's investigate when if it's continuous at 3 or not. Now remember that a function is continuous if the limit as x approaches a number at the given function is equal to f of that number. So this number, so as x approaches this number, the function, the value of the limit is equal to the function at that number. Okay, so just to give you an example, so if I say the function is, say, x plus 3, so the limit as x approaches, say, 2 of x plus 3, the limit of this is equal to 2 plus 3 equals 5 by substitution. Now f of 2 rather is equal to, remember, f of 2, you substitute the 2 to x and then you get 2 plus 3, which is equal to 5. So the limit of the function as x approaches 2 is 5, the f of 2 is 5, they're the same, so that means it is continuous at x equals 2. So key idea is you have to check whether this is true. If this is true, then you can say it's continuous. Okay. Now at the same time, since we're talking about the limit, to get the limit as x approaches a particular number, we have to check the limit as x approaches from the left and from the right of the given number before you can conclude for the value of the limit as x approaches that number. Okay. Now to further explain the idea, let's tackle this function. So let's start with x equals 3. So at 3, we need to check what is the limit as x approaches 3 of the function, and let's identify what is f of 3. If it turns out that these two values are the same, then the limit, the function is continuous at 3. That's all we need to do. That's all we need to show. If these two are the same, then the limit is continuous at that number. Now, how do we find the limit as x approaches 3 of a given function? So, to get the limit as x approaches a number, we need to check the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. So, you have to get the limit of the function, 3 from the left and 3 from the right. Now, this can be a little tricky. So, let's investigate what is the limit as x approaches 3 from the left. Now, the function is a piecewise function. So you have three options what to place here. Because remember, the function can be -3 minus x, it can be 9 minus x squared, and it can be 6x minus 18. So how will you determine whether this should be the function, or this should be the expression to the function, this should be the expression to the function, or the third one is the expression to the function? The key here is from where you're approaching the number. You are approaching 3 from the left of 3. So definitely the x values are smaller than 3. So when you check which interval contains those x very close to 3, then this is the interval that you need. See, you want to consider numbers very close to 3, so that means those numbers are part of this interval. So at this particular limit, we have to use 9 minus x squared. And by substitution, the limit will be 9 minus 3 squared. The limit is equal to function should be used is from this one. X approaches 3 from the right. So you're approaching 3 from the right, so those numbers should be bigger than 3. And that interval will contain those numbers at x greater than or equal to 3. So the function to be used is 6x minus 18. Okay, I hope that is clear so far, because that is very when finding you have to really use the concept of limits. So here 3, going back, so this is 3 from the right. Those numbers are bigger than 3, so the function should be 6x minus 18. And then if you get the limit through substitution, this is 6 times 3, 18 minus 18, this is also equal to 0. Again, what did we say about getting the limit as x approaches a particular number? So the limit as x approaches a particular number is defined when the limit from the left and from the right are the same. So obviously this is 0, this is 0, they're the same. So the limit as x approaches 3 of the function is equal to 0. Now, what is f of 3? Similarly, you have 3 options of for the expression. You're looking for f of 3. So that means you have to get the interval, or you have to get the function in which the interval contains that value of 3. It cannot be at 9 minus x squared, because the allowed x here are from negative 3 to less than 3. It didn't say, oh, you include 3. No. Okay, so you don't use 9 minus x squared, but instead you use 6x minus 18, because at this function the x has the 3, because it says x greater than or equal to 3. So f of 3 is equal to 6 times 3 minus 18, and this is also 18 minus 18 equal to 0. So the limit of the function as x approaches 3 is 0, equal to the function at that number, which is also 0. Therefore, we say that at x equals 3, the function is continuous. Okay? So I'll be leaving to you how you determine whether this will be continuous or the function will be continuous at negative 3. So apply the same idea. You're just replacing 3 by negative 3. Obviously, the function will change depending on where the negative 3 is. Okay? So just study my solution for x equals 3, and for sure you'll be able to answer the one for negative 3. Now don't forget to identify the type of discontinuity. It could be a jump, it could be an oscillating, it could be a removable discontinuity. Okay, so that's it.